Hi, I'm Juan Loaiza, and I'm going to talk about how the Oracle Autonomous Database works. So first of all, traditionally when we created databases, each deployment was unique. And you had to be the person that built the database, secured the database, repaired the database, tuned and drove the database. And of course, this was a very complex, labor-intensive process that exhibited very poor economies of scale. Now, with Autonomous Database, we're going to revolutionize database management. The full management of the database lifecycle is completely automated. And this is true even for ultra mission-critical databases with sensitive data. And this is going to enable you to innovate a lot more while paying less and ensuring data safety. Now, Oracle has been working on automating database for a very long time. And we've invested thousands of engineer years in automating and optimizing all aspects of the database. And similarly, with engineered systems, we've invested thousands of engineer years in automating and optimizing the database infrastructure. And what the Oracle Autonomous Database does is it completes this journey. We now have complete infrastructure automation. We've completed the database automation. And then we're adding to that the automation of the data center operations and the optimization of the database with machine learning to deliver the world's first autonomous database. So let's talk about how this works, starting with provisioning. So when we provision a database in the autonomous infrastructure, we rapidly and easily create a mission-critical database. And it's mission-critical because we're using all of our advanced technologies. So we create an Exadata cloud infrastructure using our real application clusters database, which is a scale-out fault-tolerant database, and also with active data guard standby so they can withstand site failures and corruptions. So it's a very sophisticated mission-critical database. Second, for security, what we've done is protect the data from both external and internal threats. So the Autonomous Database constantly monitors for threats. It applies security updates while the database is online, while the system is running. It prevents administrator snooping using our Data Vault technology. And then, of course, it encrypts all the data both in flight and at rest. Now, for management, we automate all infrastructure and database management. So we perform all OS and SysDBA operations. We tune all the settings at all the different levels. We apply software patches, again, at the infrastructure, firmware, database, all levels, fully online. And we have a lot of machine learning automation for diagnosing any errors that come up and dealing with them. Now, in terms of protection, we protect from any kind of failure without downtime. And we do this by automating all the backup and restore functions, but also by implementing an application transparent failover, both within the scale-out cluster and across to a different region with our active data guard standby. Now, scaling is something that's very different in the cloud with Autonomous Database. We're able to scale online to achieve both the best performance and the lowest cost. And we're able to do this with something we call instant online elasticity, using our serverless compute and storage infrastructure. So what this means is we can scale up both the CPU and the storage instantly. So you can grow your CPU, grow your storage, and shrink it. So when the system is busy, we can grow it. When it's less busy, we can shrink it. And this enables true pay-per-use, which really lowers the cost because you're only paying for the resources you use rather than the system that you typically get on-premise, which is the maximum possible size that you'll ever need. Okay, for optimization, database optimization, we've implemented a lot of machine learning algorithms to optimize the database for each workload. So the Autonomous Database continuously optimizes the memory, the data formats, the indexing, the parallelism, and the plans for each workload. And I'll get into a little more detail on that. Okay, there's one Autonomous Database, but we've optimized it by workload. So we have basically two solutions. One we call the Autonomous Data Warehouse, or ADW. And this is targeted at data warehousing, data marts, data lakes, and machine learning. We have a second offering called the Autonomous Transaction Processing, or ATP. And this is targeted to handle transactions, but also complex workloads within the transaction processing, like batch, reporting, and IoT. ATP is also used for application development, and it also can run integrated machine learning. So now let's talk about some of the things we've done to optimize each of these different offerings. So we specialized these by workload. So for example, the autonomous data warehouse by default loads all data in a columnar format because that's the most optimal format for running analytic workloads. On the other hand, ATP loads the data in row format because that runs much faster for transaction processing. ADW will automatically create data summaries to accelerate processing, whereas the ATP database automatically creates indexes online to speed up transaction processing. In terms of how we use memory and optimize the system, ADW uses most memory to optimize parallel joins and aggregations, whereas in ATP, the key is to reduce response time, so we use most of the memory for data caching to avoid I/O and get faster response time. And both of these, we update the optimizer statistics in real time to ensure that the SQL statement plans are completely optimal, and we have very sophisticated mechanisms to prevent plan regressions. Okay, so I want to show you some real-world results of all this optimization. So starting with autonomous data warehouse, we took multiple customer workloads, real-world customer workloads, that the customer tuned over many years by adding indexes, partitioning, compression, etc. And we ran the exact same workloads on the autonomous data warehouse with no tuning whatsoever. And what we found is we were able to achieve better performance with our automatic tuning than the customer did after decades of manual tuning. And because of the machine learning constantly runs, the workloads will stay tuned. They don't just get tuned once and then go out of tune when the workload changes. Similarly, for autonomous transaction processing, we took a NetSuite highly complex workload that included over 17,000 SQL statements, 1,800 tables, and in that workload, the NetSuite team had built 8,000 indexes over many years of tuning, and we ran the exact same workload on the autonomous transaction processing, but first deleting all the indexes and statistics and everything else, and we let it tune the workload automatically. And what you see here is we were able to achieve almost exactly the same performance, in fact, slightly better than all the hand tuning was able to achieve with significantly fewer indexes. And again, because the system is tuning all the time, it's going to stay tuned even when the workload changes. So these are great results for both data warehousing and transaction processing using our new machine learning algorithms. Okay, when you deploy either a ADW or an ATP database, you have two choices. You can just deploy the database automatically within our public cloud, or you can choose what we call dedicated Exadata cloud infrastructure. And dedicated Exadata cloud infrastructure provides the highest possible isolation. So the idea here is that the complete stack is isolated from other tenants. And what I mean by that is not just the compute, but the compute, the storage, and the cluster interconnect are dedicated to that specific customer. And it's walled off from every other customer in the cloud with a hardware-enforced virtual cloud network. And what this provides is essentially a fully isolated cloud inside the public cloud. So it's like a private cloud running in the public cloud that's completely isolated from everyone else. So that's an option for customers that want more isolation. In here, we also provide a lot more choice on consolidation and how software updates happen, how and when software updates. And in this infrastructure, we're able to give a 99.995% availability guarantee. So that's less than 2.5 minutes of downtime per month, and that includes all planned downtime. Now that I've described how the autonomous database works, let me tell you about some of the benefits of the autonomous database. So first of all, the autonomous database enables you to spend much less. It eliminates the tedious, expensive, and unsafe manual database management. It also enables you to cut runtime costs up to 90% because it uses ultra-efficient Exadata infrastructure. It uses machine learning to continuously tune itself, and you pay for only the compute and storage resources that you use, not for the maximum that you might use. A second big benefit is that it allows you to innovate much more. So application developers can instantly create an autonomous database that's self-tuning, so they don't have to spend a lot of time doing the tuning and management of the database. And also, administrators can be refocused on creating more databases and getting more value of the data to create more business value. Autonomous database also ensures data safety. So the continuous online updates protect against cyber attacks and data thefts. And also, it's a highly fault-tolerant solution. So it guarantees uptime, including maintenance from any kind of failure, including hardware failures, human errors, and site disasters. Thanks for joining me today, and I invite you to think autonomous and revolutionize your database management. You can try it now by getting a 2 terabyte autonomous database for free for 3,300 hours by visiting us online. Thanks again for joining me today.